welcome back. Today we're going to be talking about 5.2, proving trig identities. Now, if you watch the first video, 5.1, this is going to look kind of familiar. And what I'm trying to tell my students is this. You are going to struggle with this at first. That's okay. It's going to be a process where you start to recognize things that happen, but that's going to take a little bit of time. Students don't like to hear that. We want to get it right now. And it feels good to get things. Like to understand something, we want to do it. We want to understand it right away, or we get defeated. Don't get defeated. This is a pep talk. Don't get defeated. Feel normal if you don't get this. And so by the end of this video, I'm hoping that you start to recognize some of these strategies. We're using algebraic principles on these things. We're recognizing opportunities to substitute out. We're finding common denominators. We're using distributive property. Those are algebraic principles. And we're really working on seeing opportunities to sub things out from this sheet. Okay, so let's go. Excuse me. I'm a little under the weather, as you can tell. Got a little sniffle. Feel good, but anyway. All right, so we're going to start here. And here's a strategy for you. The strategy on this one is start with the ugliest side. What does that mean? Well, if our goal is to prove or our goal is to simplify, it's easier to simplify something that's more complicated than it is to simplify something that's already simple. Okay? So when we're proving, I want to show that, so prove means show true. So I want to show that side A is truly equal to side B. Well, we'll take a look here. I've got this addition problem here. That's got a tangent and a cotangent. And I've got a secant and a cosecant. Well, just think about this for a second. All things being equal, both sides have two things, right? Tangent, cotangent, secant, cosecant. Neither one of them involves really sines and cosines yet, although we see some substitutions, hopefully. And so all things being equal, they have two terms. Nothing is in terms of sine and cosine, so which side is more complicated? Well, this side is actually more complicated, and here's why. When we have addition and subtraction with trig ratios, it means we're going to use strategies like common denominators. We're going to use strategies like double angle formulas or angle sum and angle addition formulas. We're not going to use those today, but those are the kinds of things we're looking for. And so we're going to start with side A. So what do? Well, check out your sheet. I don't see tangent plus cotangent on here anyway, and that's okay. However, something I can do now is I am going to convert to sines and cosines and see what happens. And hopefully now it becomes a little clear, like, oh, wait a second. Wait a minute, I'm going to erase this. I want to limit myself on space. I have these fractions. Well, what do I do with fractions when I'm supposed to be adding them? For this, I need to find a common denominator. So here we go. The common denominator of cosine and sine is sine. So I've got sine x over cosine x times sine x over sine x plus cosine x over sine x. And I want to multiply that one by cosine x over cosine x. So check out what we've got here. First part, sine squared x. Hopefully you're recognizing that's part of a Pythagorean identity. I don't know if it's the whole thing, but sine squareds are actually okay, right? It seems more complicated than a sine, which it is. But if I start to have a sine squared or a cosine squared or a 1, that's an element of one of those Pythagorean identities right over here, right? Okay. So sine squared x over cosine x sine x plus cosine squared x over sine x cosine x. And these denominators are common. So what do I have? Well, this is actually really good. Hopefully you see it. Sine squared x plus cosine squared x over my common denominator of cosine x sine x. What do you see? This is a Pythagorean. Okay, that's Pythagorean identity. It's equal to 1. So now I have 1 over cosine x. I'm trying to keep things the same here. Cosine x times sine x. Check this out. If I have the 1 on top and 2 things on the bottom, I can split that and make it a multiplication problem. So I can say this is 1 over cosine x times 1 over sine x. Check it out. Well, okay. How do I know to do that? Well, check it out. I'm trying to prove that this is true. And the beauty of this is you know that it's true. When they're saying prove, they're saying just show that it's true. So to have the last line be, you know, the two sides are equal is good. That's what you want. But in the meantime, you get to this part right here where this seems pretty simple. Well, look at what I want it to be equal to. I want it to be equal to 2 things, a multiplication problem. And so how do I know to split it? Well, look, I want a secant and I want a cosecant. Well, look what I've got here. 1 over cosine is a secant x, and 1 over sine is a cosecant x. And so what I've got is, that's it. Okay? So secant x times cosecant x is equal to secant x times cosecant x. Why am I writing this? Because I have to show that one side equals the other. Okay? So that's true. So look for substitutions, convert to sine and cosine. I used common denominators in this. I looked at my goal, meaning I looked at what I wanted it to be equal to and had to split, which was fine. Okay, here we go. So this one's a little bit trickier. It says match the function. So I've got f of x is equal to 1 over secant x minus 1 plus 1 over secant x plus 1. And I got to match it with one of the following using a proof. Okay, so where do I go? Unlike the first one was cool because they said, hey, here's what it equals. So this one we have to be a little bit more strategic. But there are things we can see as we get more experienced with this that are going to help us. What do you see here? Well, what I'm seeing is an addition sign. So I'm thinking my strategies. I'm thinking I'm going to have to use common denominators. Right? Common denominators. I'm seeing a secant x minus 1 and a secant x plus 1. I'm kind of thinking ahead. I know I'm going to have to multiply like secant x minus 1 times secant x plus 1. I'm thinking it's going to be a difference of squares, right? I'm just thinking ahead, right? I'm thinking ahead about what's going to... And difference of squares looks like this. Let me make it less abstract. X minus 2 times x plus 2 is equal to x squared minus 4, right? So difference of squares means when I multiply the same two terms, but the sign is different between them, I'm going to end up with a difference of squares, meaning a something squared minus a something squared. So I'm thinking about that. So let's just forget about these for a second. I don't know what it's equal to. I'm just going to forget about those for a second. And I'm going to start working with this. So let's rewrite. Grab a blue here. 1 over secant, I guess I grabbed purple. 1 over secant x minus 1. And I'm going to go common denominators right away. Times secant x plus 1. And then plus 1 over secant x plus 1 times secant x minus 1 over secant x minus 1. And so let's do a little bit of rearranging here. So on the top I've got secant x plus 1 plus secant x minus 1. On bottom, I'm going to leave this for just a second and see what happens. Let's see, secant x minus 1 times secant x plus 1. Okay, let's see what happens. On top here, check it out. I've got a plus 1 and a minus 1, so those go away. And I've got 2 secants, so I'm going to have 2 secant x over secant x minus 1 times secant x plus 1. Okay, so I'm going to check back in now. So let's look. I've got, I did something, right? I at least combined them. That's a step. Does it equal any of these things? No, I like this. right? I sort of see that, and I'm like, I got 2 up here, but I got to make it look like that. So now here's what I'm going to do at this point. I'm actually going to play on this difference of squares. I'm going to do it. Do that bottom operation. So 2 secant x over, and I'm going to do the shortcut here. I'm going to have secant squared x minus 1 on bottom. Okay, so at this point, I'm kind of stuck. I don't know what I see. I can't reduce this. So I'm going to look at my identity sheet. And I'm looking for something that looks sort of like either the top or the bottom. And what I'm seeing is this right here, this Pythagorean identity that involves secant x. And I'm curious about what actually that might mean, because it's not one of the identities proper, meaning it doesn't immediately look like it. But check it out. If I look at this Pythagorean identity, and I've got tangent squared x plus 1 equals secant squared x, something that helps me personally, this is me personally solving these problems. When I see an expression that involves 2 of these things, so in my mind there's 3 parts here, tangent squared, 1, and secant squared. If I've got an expression that involves 2 of them, I immediately look to sub it out, meaning I know if I've got 2 of them, then I can swap it out for the other one because they're equal, right? So if I rewrote this, tangent squared plus 1 equals secant, so if I subtracted 1, then tangent squared x is equal to secant squared x minus 1. Okay, so on the bottom, now I can go to tangent. Remember, this is our hierarchy. Cosecants and secants, I don't want. I want to get away from those. Tangents are slightly less bad, and then sines and cosines are what I actually want. So it's a good sub, in my mind, to take away a secant and to put in a tangent, especially if it's a secant minus 1. So I got 2 secant x over tangent squared x. This is good. Now I'm going to rewrite in terms of sine and cosine. So 2 times 1 over cosine x over sine squared x over cosine squared x. And so I'm going to rewrite, because this is actually equal to 2 over cosine x times cosine squared x over sine squared x. Right? Multiplying by the reciprocal is the same as dividing by a fraction. And so I'm left with 2 cosine x over sine x, sine squared x. And what have I got here? I'm going to check back in and look and see, is it one of these? Well, I'm pretty close, right? It looks like, so this 2 is still very intriguing to me. And so I'm going to see if I can write this as cotangent cosecant. Well, look, 2 times cosine x over sine x times 1 over sine x. Right? Factor out a 1 over sine x. And so this is equal to, I got to scroll, 2 times cotangent x times cosecant x. Okay, so my answer is A for this one. So what did I do? I saw an addition problem, so I thought common denominators. I saw that the denominator was going to give me a difference of squares. I used that. And then later in the problem, I saw a secant squared minus 1 here, and I subbed it out for a tangent squared. Like I said, seeing these things, recognizing the possibilities is the hardest part, but you can do it. Let's look again. Prove. This one's good. This means show true. So I know that this is true. It wants me to pick the ugliest side. Well, I am telling you that. So which one's ugliest? I don't know. It actually doesn't really seem to matter. And so let's just start. Let's just go. Let's just do it. I'm going to go this way. I'll just start with the left side. And I don't really know what to do. But what I do see is that on the other side, if I'm going to show this true, I need a 1 plus sign on top. Well, I don't have 1 plus sign on top. That's the beauty of this, guys. When you are proving, you know that it's true. And so if you're starting with a side, and it's got to look like the other side, just look, observe. And so this right-hand side here, it's got a 1 plus sign. I don't have a 1 plus sign. So let's put one there. Cosine t times 1 plus sine t. Just do it. Do it. And so on the bottom, I can't multiply the top without multiplying the bottom by the same thing. 1 minus sine t, and then 1 plus sine t. Check it out. This is difference of squares on the bottom. So check this out. I've got cosine t, 1 plus sine t. On the bottom, I've got 1 minus sine squared t. Again, recognition, Pythagorean identities. Check it out. I have this one right here. Sine squared plus cosine squared equals 1. So I see two of the elements. Sine squared plus cosine squared x equals 1. I have two of them here. So if I subtract sine squared cosine squared x is equal to 1 minus sine squared x. Again, that's recognition, being familiar with the formula, seeing a 1 and a sine squared, subbing it out. So, come up here. Cosine t on top, 1 plus sine t. On bottom, I got cosine squared t. Well, look at what happens. Boom, boom, boom. Cosine goes away. So on top, 1 plus sine t. On bottom, cosine t. Check it out. Boom, right there. Looking at the sides and seeing what do I need to have for this to be true. Okay, check it out. Here's a bonus example. You have everything you need to do these problems, but here's a bonus example. So this one's actually going to play on working with both sides at one point. Kind of spoiled the surprise. But here we go. Pick the most complicated side. All things being equal, these are both pretty complicated. This one has a fraction though. Okay, so it's got a fraction. So I'm going to start with that. If I look at this top part, and I'm looking at my sheet, and I'm trying to figure out what to do. Excuse me. I'm trying to figure out what to do, and I see this cotangent squared. I don't see that a lot. And so what I'm going to do is, I'm going to look at my Pythagorean identities right here, and I'm going to see that cotangent u is actually equal to cosecant squared u minus 1. Okay? And on bottom, I've got 1 plus cosecant u. This one's a little bit tricky, okay? Because that substitution doesn't seem natural, but I'm telling you, sometimes you want to sub to something that's going to give you, see I had a cotangent, and the beauty of this is now I have a cosecant on top and a cosecant on the bottom. Cosecant on top and cosecant on bottom. Well, check this out right here. Difference of squares. Right? So this is cosecant u minus 1 and cosecant u plus 1. Ooh, look at this. These cancel out. So I've got cosecant u minus 1 on this side. That's actually pretty good. It doesn't equal the other side though. So what am I going to do? So now, at this point, I'm going to do something I don't normally do, but I'm sort of stuck. Being that it's equal, I'm going to work with the other side for just a second and see if I can make this look like what I now know the other side to be equal to. So I've got cotangent. And this is somewhat reasonable because, look, I've got a subtraction problem over here now, and over here I have a subtraction problem in here. So they sort of are starting to look more alike. When I had a fraction equal to a distributive property problem looking thing, that didn't seem to be close, but this seems kind of close. So I'm actually going to do this. Cotangent u times secant u minus cotangent u times tangent u. And so if I multiply this together, so this is cosine u over sine u times 1 over cosine u minus, now these are reciprocals of one another, so they're going to be 1, but I'll write it out so you can see it. Cosine u over sine u times sine u over cosine u. This is 1, minus 1. Ooh, this is good, look. These cancel out, so I've got 1 over sine u So I've got cosecant u minus 1 is equal to cosecant u minus 1. Okay. Hardest part, students will say, how do I take the first step? The first step on this one is tough. Knowing to sub out cotangent u for cosecant u minus 1, but it's a strategy. Okay, look for things you can substitute. I hope you start to see that these times you have these identities squared are times you can use Pythagorean identities to sub them out. Okay, thanks for watching, guys, and we'll see you next time.